the quietest breath of the cosmos, when ancient light still wanders through the black corridors of space, James Webb has whispered a secret that shakes the foundations of cosmology. A trace, older than the Big Bang itself. As if someone had written a chapter before the first page of the book called the universe, then tucked it gently beneath layers of time. If this is true, we are not just mistaken. We have misunderstood everything from the root. And the journey to unravel this mystery offers not only knowledge, but a stirring sense of awe that the universe's history may be far longer than we ever imagined. Share your thoughts below. If there was an era before the Big Bang, what do you think it looked like? And now, to understand why this revelation matters so profoundly, we must begin with our own home. Why did humanity measure the Milky Way wrong? In the soft twilight of our understanding, when human curiosity drifts like a lantern across the deep, a quiet truth rises from the dark. For 70 years we believed we knew the size of our own cosmic home. A neat figure repeated in classrooms, textbooks, diagrams, and even whispered with confidence by generations of astronomers. 100,000 light years. A number so familiar, it became almost sacred. Yet, like many stories told from the inside looking outward, it was incomplete. Softened by our blind spots. Shaped by the limits of the tools we once trusted. Astronomer Vera Rubin once said, "The universe is under no obligation to make sense to us." And in the tale of the Milky Way's size, this sentence glows like a northern star guiding us through the fog of our own assumptions. For decades we traced the galaxy's silhouette by counting bright stars, watching them thin into darkness, and drawing a line where our eyes could no longer follow. It felt reasonable. It felt scientific. But the cosmos does not yield its borders so easily, especially to creatures living inside its swirling arms. Imagine measuring a forest while standing beneath its tallest tree. Imagine mapping an ocean while floating in a tiny wooden boat. That is what humanity attempted. We looked outward from our position deep within the spiral, wrapped in dust clouds and star fields, surrounded by brilliance that both illuminated and hid the truth. In such a place, even light can be a deceptive companion, guiding us while also blinding us. The old methods were charming in their simplicity. Count the bright stars, chart their density, and assume that where starlight fades, the galaxy ends. But the universe is not a city with street lamps marking the last road. It is a fluid landscape where light thins slowly and matter dissolves into mist. The Milky Way does not cut itself sharply against the void. It blends, stretches, drifts. And so for 70 years our measurements stood, elegant and wrong. The turning came not with a single telescope, but with a symphony of instruments, a harmony of perspectives woven across wavelengths and distances. Gaia began to chart more than 1 billion stars with exquisite precision, each one a bead on an invisible thread tracing the gravitational truth of our home. Radio surveys reached outward into the cold, mapping hydrogen clouds that quietly extended beyond every textbook boundary. And then the James Webb Space Telescope, our golden eye in the dark, began peeling away the layers of dust that hid the galaxy's farthest outskirts. One by one the clues gathered, like whispers converging into revelation. The streams appeared, rivers of stars torn from devoured, dwarf galaxies, their orbits looping far beyond the old map. These streams were honest in a way starlight alone could never be, because they followed gravity rather than brightness. And gravity never lies. Astrophysicist Wynne Evans once remarked, "Stellar streams are the fossils of a galaxy's past and the rulers of its true shape." And in their elegant arcs we discovered something startling. The Milky Way was not 100,000 light-years across. It was closer to 200,000. Perhaps even more. A quiet doubling. A gentle correction. But one that rippled through every equation born from our earlier belief. The galaxy we thought we knew had always been larger, heavier, more intricate. Its halo stretching like a ghostly kingdom far past the reach of visible stars. When I sit with this discovery, I feel something strangely tender, as if the universe is gently reminding us to stay humble, to keep our instruments sharp and our minds soft. Perhaps the mistake was inevitable. After all, we were trying to outline a mountain while standing inside its cavern. And there is something comforting in the thought that we are still learning the contours of the place we call home. That even now the Milky Way is revealing itself petal by petal. The presence of dark matter complicates everything, wrapping the galaxy in an invisible sphere that extends beyond imagination, pulling stars into swift, improbable orbits. Rubin's work decades ago hinted at this unseen mass, but now Gaia and JWST have allowed us to feel the weight of that halo with unprecedented clarity. And when you measure a galaxy by its gravity rather than its glow, the Milky Way stretches outward like a cosmic tide. Astronomer Carlos Frenk once said, "Without dark matter our galaxy would simply fall apart." A poetic truth hidden in the mathematics. The very fabric that binds us extends far beyond what light alone reveals. And this is what the streams taught us. They drift through the outer halo in graceful arcs. Proof that the Milky Way's gravitational hand reaches farther than any previous measurement had dared to imagine. As the data grew, the old picture wilted, pixel by pixel. The new size changes how we estimate star counts, how we model galactic collisions, how we map the local group. Even Andromeda's eventual dance with us begins earlier in this revised cosmos. Halo, touching halo, long before any star meets another. Under the soft glow of this updated truth, I find myself wondering about the stories we cling to, the edges we draw, the boundaries we imagine simply because our eyes cannot see beyond them. Measuring the Milky Way from within is a humbling reminder that knowledge is a lantern with a limited flame, illuminating only what lies nearest, while the greater night stretches endlessly outward. And the lesson I carry from this revelation is simple, gentle, almost meditative. We must remain curious enough to question even the truths that feel most familiar, brave enough to redraw our maps, and calm enough to accept that the universe will always be larger than our first attempts to describe it. As you listen, drifting perhaps between wakefulness and the kind of quiet that lets thoughts settle like cosmic dust, let this new understanding wrap around you. Our galaxy is bigger, more ancient in its movements, more mysterious in its edges, and we are still learning to read the language of its shape. If this sparks wonder in you, or a question, or simply a quiet breath of awe, share it in the comments. your thoughts, are part of this cosmic conversation too. And as we float forward together through this story under the banner of cosmic perspective, we drift into the next mystery waiting for us in the dark. Why did humanity believe for so long that the Milky Way ended where the stars seemed to fade? And what deeper truths lie beyond that fading light? As we drift outward from the warm cradle of the solar system, beyond the glittering haze of the local arm, a strange whisper begins to move through the darkness. It is the whisper of motion, the language of stars. And the farther we listen, the more we discover that the outer edges of our galaxy speak in a tongue that seems to contradict everything we believed about gravity. For reasons that once puzzled even the brightest minds of astrophysics, the stars at the rim of the Milky Way race around the core at speeds that should fling them outward into intergalactic night. They move too fast, too boldly, too confidently for the mass we can see. As Vera Rubin once said, "What you see in a spiral galaxy is not what you get." Her words still echo like a quiet bell across decades, telling us that something unseen is gripping the galaxy with gentle but unyielding hands. If only visible matter existed, the Milky Way should have unraveled long ago. The stars should scatter like sparks rising from a dying fire, drifting into the void with no force strong enough to hold them close. And yet, they stay, obedient to an invisible rhythm. It is as though the galaxy is a dancer, swirling through a ballroom of emptiness, and an unseen partner keeps her steps steady. That partner is what we call dark matter, an entity as mysterious as it is necessary, the quiet architect of structure in the cosmos. Fritz Zwicky once described it as dunkel materia, dark material, because he could see its fingerprints but not its face. And today, nearly a century later, we still cannot touch it, cannot bottle it, cannot force it to reveal its true identity. But we can measure the way it cradles our galaxy. And in that cradle we find both wonder and humility. The halo of dark matter surrounding the Milky Way is not a thin ring, not a faint border, but an enormous sphere of influence that extends far beyond the reach of the luminous disk. Some estimates suggest 250,000 light-years. Others whisper 400,000. And a few daring models stretch its arms to nearly 1,000,000 light-years. A ghostly empire of matter we cannot see, yet cannot deny. If we could watch the galaxy from outside, we would not see a clean spiral cut sharply against the darkness. We would see a soft glow diffusing outward, thinning gently, blending into the cosmic sea. A reminder that galaxies do not end where the light ends, but where the gravity fades into silence. This is why the question, how wide is the Milky Way, is both simple and endlessly complicated. If you only measure the bright disk, you might think 100,000 light-years. If you measure where stars become rare, perhaps 150,000. But if you measure the domain where matter obeys our galaxy's pull, the so-called virial radius, then you arrive at a very different picture. Somewhere near 200 to 250,000 light-years. A radius that is not defined by light, but by loyalty. Neil deGrasse Tyson once mused, "We are part of a grander structure than we can see." And nowhere is that statement more literal than the invisible reach of the dark matter halo. The virial radius is not a poetic term, though it often feels like one. It is the gravitational frontier, the border where the Milky Way's influence still holds objects in a vast, slow orbit. Inside this sphere, stars, gas clouds, and even dwarf galaxies move as part of one collective family. Outside it, the galaxy's call weakens, and the endless tug of the universe begins to dominate. The virial radius is not the end of the galaxy, but a suggestion. A threshold where the boundaries blur the way dawn blurs night. For some listeners, the notion that the galaxy does not have a true edge feels unsettling. We humans love borders, love maps, love lines that tell us where one thing stops and another begins. But the cosmos rarely agrees with our need for neatness. A galaxy fades into space the way a sigh fades into silence. Gradually, gracefully, like breath dissolving into cold morning air. And perhaps it is fitting that a universe born from expansion, from stretching, from flowing outward, does not grant its creations sharp edges. Many astronomers have tried to imagine what the galaxy looks like from afar. A shimmering disk suspended inside a delicate cocoon of unseen mass. The idea itself carries a soft beauty, as though the stars are a lantern, and dark matter is the glass that protects the flame from the winds of space. Without this invisible container, without this hidden sphere of stabilizing force, the galaxy would come undone, its stars scattering like pollen across the void. But even as we try to imagine these vast shapes, there comes a moment when the science quietly invites us inward, encourages us to slow our breathing, to rest the mind on the image of stars moving through darkness. For in contemplation, we begin to sense something profound. The mystery of dark matter is not simply an astrophysical puzzle. It is a meditation on humility, a reminder that most of reality lies beneath a veil we cannot yet lift. As cosmologist Sean Carroll once reflected, the universe is under no obligation to make sense to us. And dark matter seems to embody that quiet refusal. Yet, despite its invisibility, its elusiveness, we know it is there because its gravity sculpts the galaxy with the patience of a sculptor smoothing stone. Its fingerprints lie in every orbit, every star that refuses to fly away, every spiral arm that holds its graceful shape for billions of years. Without dark matter, the galaxy would be a fleeting swirl, a blossom scattered on cosmic winds. But with it, the Milky Way becomes a stable and elegant garden, a vast arrangement of lights drifting in harmony through time. As we drift further in this thought, the narrative of stability blends into a deeper question. Where does the galaxy end? And where does the universe begin? There is no crisp frontier, no cosmic cliff where matter stops and emptiness starts. Instead, there is only transition, a slow dissolution of density, like ripples losing strength as they travel outward on a moonlit lake. Astronomers have chased the boundaries of the galaxy with instruments that see far beyond visible light, revealing faint streams of stars that wander hundreds of thousands of light-years from the core. These stellar streams are like old stories, echoes from galaxies devoured long ago. They wander so far into the halo that they challenge all previous estimates of size. And in their long, slow arcs, we see the true reach of the Milky Way's gravitational heart. It is moving to realize that the stars we see are only the visible petals of a much larger bloom. That most of the galaxy is not shining, but sensing, not glowing, but guiding. That the brightest parts are merely the embroidery on a much larger invisible cloth. And in that cloth, woven from matter we do not yet understand, lies a quiet truth. The universe is deeper than our eyes, older than our measurements, and more patient than our curiosity. It reveals itself slowly, gently, like a tide rising in darkness. And as we drift through these mysteries, in the soft glow of cosmic ignorance, we discover that wonder is not the enemy of science, but its oldest companion. Somewhere in this meditation, we come to understand that dark matter is not just a placeholder in our equations, not a symbol for ignorance, but a bridge, a reminder that even in the quietest corners of the cosmos, unseen hands hold everything together. And as we breathe with the rhythm of the galaxy, listening to the silent partners that keep its stars from flying away, we begin to sense that the beauty of the universe lies partly in what it hides, and partly in what it reveals when we dare to look deeper. In this gentle darkness, in this cosmic hush, the Milky Way continues to turn, held not by light, but by mystery. A reminder that our journey is only beginning, and that every question we ask opens a door to a wider and more wondrous sky. In the soft drift of the cosmic night, when the Milky Way stretches like a pale whisper across the dark, a quiet truth begins to rise from the orbits of its smallest companions, the satellite galaxies that circle us like forgotten moons. For decades, astronomers believed these dwarfs were gentle wanderers, passing guests in the gravitational courtyard of our galaxy. But as precision deepened, as Gaia traced their paths with the delicacy of a calligrapher's hand, a deeper story began to unfold, a story that suggests our home is far larger, far heavier, far older in its quiet gravity than we ever allowed ourselves to imagine. The large Magellanic Cloud moves with a grace that belies its mass, a swirling ember floating 160000 light-years from us. Its orbit is too tight, too fast, too bound to a galaxy that textbooks once claimed was only half as wide. The small Magellanic Cloud follows like a smaller echo, tugged and stretched and sculpted by the Milky Way's invisible hand. And Sagittarius, a fragile dwarf long caught in our gravity, now dissolves like ancient sand, scattering its stars across the night in long tidal ribbons. It is from these motions, these slow, graceful arcs across the darkness, that astronomers first sensed the discrepancy. If the Milky Way were merely the lightweight structure we once taught, a tidy disk 100,000 light-years across, these dwarfs would not be orbiting the way they do. They would drift loose, escape, fall outward into the local group like leaves carried off by a soft wind. Instead, they cling to us, as though the Milky Way's gravity extends farther than the edge of its visible light. The great astrophysicist Simon White once said, "Galaxies cannot hide their mass from the orbits of their satellites. Gravity always reveals the truth." And in the case of our galaxy, the truth is astonishing in its scale. Because, as these dwarfs orbit, they shed stars like drifting petals, stars torn away by tides older than memory. These stellar refugees stretch across the sky in thin, shimmering lines, streams of light that trace invisible boundaries. When astronomers map their shapes, their curving paths, their aphelia and pericenters, they see a gravitational field that extends far beyond the pale disk we can photograph. The GD1 stream looks like a cosmic filament plucked from a harp, stretched taut across the halo. It should not exist where it does. Not if the Milky Way ended where our eyes once thought it did. The Sagittarius stream wraps around us like a luminous river, curling through the halo with the patient certainty of a story retold through millennia. It reaches into regions we once believed were empty, territories beyond the supposed edge of the galaxy. And the orphan stream, lonely and exquisite, wanders at distances that used to be considered intergalactic space. Yet there it flows, unmistakably shaped by the Milky Way's unseen mass. If the halo ended at 5,000,000 or even 8,000,000 light-years, these streams would unravel, dissolve, lose coherence in the emptiness. Instead, they persist, coherent, gravitationally bound. Astronomer Vasily Belokurov put it simply: stellar streams are nature's handwriting, and the galaxy's gravity is the ink. And as we read the handwriting, the Milky Way's true size comes into view. The halo is not a gentle envelope around the disk. It is a sprawling kingdom, an ocean of invisible matter stretching hundreds of thousands of light-years into the dark. Every torn star, every stretched stream, every tilted orbit whispers the same message. We have underestimated our home. We have been living inside a cosmic giant, a leviathan with a heart of stars and a body made mostly of darkness. As the satellite galaxies move, they do not simply orbit. They testify. Their motions reveal the weight of the unseen, the colossal dark matter halo that surrounds us. It is not a faint shell, but a vast sphere that may stretch to 2,000,000, 3,000,000, perhaps even 4,000,000 light-years from center to edge. The astrophysicist Katherine Johnston once reflected, "If you want to know a galaxy, do not look at the light. Look at what the light is doing." And when we follow that advice, the darkness becomes a map. These dwarf galaxies, once humble, now emerge as cartographers of the unseen realm. Their disrupted bodies, their elongated tails, their asymmetric shapes tell of a gravitational pull too strong to belong to a middling spiral galaxy. Instead, we see the fingerprints of a titan. And as we trace each stellar stream, we find connection after connection. The halo is not a void but a tapestry, woven from countless ancient collisions. Dwarf galaxies, devoured across cosmic time, their stars now drifting like ghostly survivors across the breadth of the halo. These streams tell us that the Milky Way's mass is not simply increased a little, it is multiplied. The gravitational pull required to guide them demands trillions of solar masses, far surpassing older estimates. We used to believe our galaxy contained the equivalent of 1 trillion suns. Now the numbers climb toward 3 or 4 trillion. This is not just a correction. It is a reframing of identity. The Milky Way is no longer a modest spiral on the outskirts of the cosmic web. It is a heavyweight, a gravitational monarch ruling a vast dark domain. And so the satellite galaxies, once seen as minor characters, rise to the role of narrators. They tell us of a galaxy too wide to map easily, too massive to measure with simple rotation curves. They show that our home is not only luminous where the stars burn bright, but monumental where the darkness stretches far into silence. In the gentle voice of Vera Rubin, the pioneer who first sensed the weight of the unseen, we know only a fraction of what the universe is made of, and we are humbled by the rest. And in that humility, the satellite galaxies become wise teachers. Their motions say that our galaxy's boundary is not a line, but a fading, not a wall, but a whisper. The Milky Way dissolves gently into the void, and yet holds fiercely to all that orbits within its reach. As the stellar streams drift through the dark, they map a realm shaped not by starlight but by gravity's quiet will. They remind us that galaxies are not defined by what they show, but by what they hold, not by their brightness, but by their influence. And so the truth unfolds, softly, like a meditation across the sky. The Milky Way is larger because its companions orbit in ways only a giant could command. It is heavier because its stolen stars form rivers that trace the weight of its invisible heart. It is older in structure because its halo is a graveyard of ancient galaxies long absorbed. And as you listen, drifting perhaps between wakefulness and sleep, imagine those streams of stars, delicate, shimmering, stretched across distances nothing human hands could ever measure. Imagine each torn star as a lantern floating on an ocean of darkness, each orbit a brushstroke, each dwarf galaxy a storyteller whispering truths older than our species. And let this thought settle gently within you, like dust on a quiet windowsill. When we look at the smallest galaxies, we learn the true size of our own. When we follow the faintest streams, we discover the enormity we live inside. When we listen to the torn stars, we hear the heartbeat of a cosmic giant. And maybe, as you breathe with the slow rhythm of the universe, you will feel the truth in the words of astrophysicist Jan Einasto. The universe is not just more strange than we think, it is more strange than we can think. Let that strangeness cradle you. Let curiosity soften your thoughts, and let wonder guide you deeper into the story of our galaxy. Because the satellite galaxies have given us their testimony, the stellar streams have drawn their lines, and the Milky Way has revealed its size not by its light, but by its pull. And in that pull, In that vast, gentle gravity, our home becomes larger, darker, more beautiful than ever before. The farther we drift toward the rim of the Milky Way, the more the stars begin to behave like restless travelers, moving at speeds that seem almost impatient, almost desperate, as if the edge of the galaxy were a great cliff of gravity and they were standing with one foot already lifted into intergalactic darkness. Astronomers have long known that the outskirts of the Milky Way do not obey the simple rules that guide the inner stars. And yet, each new measurement feels like a whisper that says we still understand so little, that we are children trying to read the sky with eyes not yet adjusted to its ancient light. Many of these outer halo stars travel at velocities perilously close to escape speed, brushing against the threshold where the galaxy's pull weakens and the void begins. And it is here that the great puzzle unfolds, a puzzle that forces us to confront the invisible structures holding the Milky Way together. When scientists first measured these nearly unbound stars, they asked the same question that echoes today. Why are so many of them moving so fast? And why do others crawl along with motions far too slow for their location? As though the galaxy were playing two incompatible melodies at once. Some stars soar with fierce velocity, propelled by ancient encounters with black holes or slingshot interactions with passing stellar neighbors, while others drift at speeds that seem to defy the gravitational balance that should define their orbits. And this contrast creates a portrait of the galaxy that is neither orderly nor predictable, but textured and alive, like a great cosmic organism breathing unevenly across thousands of light years. One of the most haunting interpretations is that dark matter itself may not be smooth or gentle, but clumped and coarse, like pebbles hidden under the sands of space-time, exerting subtle kicks that speed up some stars and slow others. Nobel laureate Vera Rubin once remarked that galaxies behave as if an invisible hand is sculpting their motion. And in these strange stars we see the fingerprints of that hand, reaching into the luminous world and stirring it from the shadows. If dark matter is indeed lumpy, then its unseen knots might be tugging at the stars, bending their trajectories, shaping their speed, making each orbit a quiet negotiation between the visible and the unseen. Yet the mystery deepens when we lift our gaze from the movements of stars to the enormous form of the galaxy itself. For even the shape of the Milky Way remains an unsettled story, swaying gently between order and chaos, between geometry and poetry. Some astronomers argue that we live in a four-armed spiral. Others insist on 5. While new surveys hint at 6, each arm winding through clouds of dust and newborn stars like rivers of glowing stone. The textbooks we grew up with showed the galaxy as a neat pinwheel, a symmetric flower blooming in the dark. But reality paints a different image, one less like a diagram and more like a garden tangled by time and gravity. Even the arm we call home, the local arm, long dismissed as a minor spur, now reveals the unmistakable weight and structure of a major branch, one stretching farther than early astronomers had ever imagined. As NASA scientist Jeffrey Hester once noted, the Milky Way is not an orderly cathedral but a construction site, still growing, still changing, still digesting the galaxies it has eaten. The local arm's surprising length and density speak to this restless growth, showing us that the galaxy we thought was meticulously mapped is still revealing new corridors and stairways, still surprising us with its architecture. The disagreement over how many spiral arms exist arises from our perspective. For we are not looking at the Milky Way from above, but from within. Like ants trying to sketch the shape of a forest while crawling on a single branch. Dust clouds veil entire regions, scattering visible light, hiding star-forming nurseries, masking the great arcs that curve around the galactic center. Infrared surveys peel back some layers. Radio telescopes reveal the hydrogen skeleton. Gaia traces the motion of 1 billion stars. But still the whole shape remains just slightly out of reach. The arms appear and disappear like illusions, weaving themselves out of density waves, collisions, gravitational murmurs that ripple through the disk. Yet within this uncertainty, there is a strange peace. For the Milky Way's complexity reminds us that even in science, beauty often lies in what cannot be fully tamed, fully categorized, fully named. Astrophysicist Carl Sagan once reflected that understanding is a form of joy, but so too is mystery. And indeed, the mystery of our galaxy deepens the more we uncover, each answer unfolding into new questions like petals opening in the dark. As we drift back toward the outskirts where this story began, those high-velocity stars still shimmer in the mind, tiny lighthouses racing through the deep, telling us that gravity is more complex than our simple equations, that dark matter may be more textured than we once imagined, that the Milky Way itself is a living tapestry, woven from collisions, births, deaths, and the quiet breathing of stars. Each star moving too fast is a reminder that something unseen is pushing or pulling, whispering through the gravitational field, sculpting trajectories with a patient hand. And each star moving too slowly tells us that structure is more delicate, more intricately balanced than textbooks could ever capture. Together they form a chorus of deviations, hints that beneath the luminous surface lies a cosmic skeleton we are only beginning to trace. So we sit here, on a small world circling an ordinary star inside an arm that may or may not be major, in a galaxy whose shape we cannot fully see, wrapped in a halo of matter we cannot touch, watching stars flee toward the edge where gravity thins and eternity begins. And as we listen to them, as we follow their trembling lines across space, we begin to sense that the Milky Way is not a structure frozen in time, but a flowing consciousness of matter and motion, a river of light pouring through the dark. In the end, these mysteries do not distance us from understanding, but draw us deeper into the gentle wonder that science can offer. A meditation on movement, on the shapes that hide within the night, on the quiet truth that even the galaxy we call home is still learning how to reveal itself to us. And with every discovery, with every velocity measured, with every arm redefined, we move one breath closer to understanding what binds this cosmic garden together. If you feel the mystery stirring in you, share your thoughts below. For the galaxy is listening. And perhaps, in our shared curiosity, we may trace one more strand of its endless design. In the soft, drifting hush of the galaxy, where stars move like ancient lanterns across a dark ocean, the question of where the true center of our Milky Way lies becomes something more than mere astronomy. It becomes a meditation on balance, on gravity, on the invisible forces shaping the home we drift through without ever truly seeing. For generations we believed the center was obvious. That the supermassive black hole Sagittarius A*, glowing faintly behind curtains of intervening dust, was the gravitational heart of everything. But science has a way of humbling us. And sometimes, the universe reminds us that truth is rarely confined to what is bright, what is visible. The Milky Way's true center of mass does not sit neatly atop Sagittarius A*, and this misalignment ripples outward into every orbit, every model, every assumption we carry about our place in the grand structure. Dark matter, the silent sculptor of the cosmos, exerts its influence not through light but through presence. As astrophysicist Vera Rubin once said, "What you see is not what you get." Her words echo stronger than ever now, because what we see at the galactic center is merely the luminous tip, while the true balance point is shaped by a vast invisible halo surrounding everything like an unseen tide. Dark matter's distribution is not uniform. It pools, stretches, clumps in ways we cannot easily trace. And as it does, it shifts the galaxy's center of mass by hundreds or even thousands of light-years. That shift may sound subtle, but on a galactic scale it is like moving the fulcrum beneath a spinning wheel. Every orbit bends differently. Every star adjusts its path, including our own sun. For the Earth, this means our 230 million-year galactic orbit is not quite the elegant ellipse textbooks once promised. It is a wandering spiral around a moving target. Like a firefly circling a lantern swayed by an unseen breeze. The sun follows a path shaped not only by the visible stars at the center, but by the curled fingers of dark matter tugging gently from afar. As physicist Janna Levin beautifully remarked, we live in a cosmic dance we barely understand. This dance grows even more compelling, even more haunting, when we extend our gaze outward toward Andromeda, our neighboring giant, our eventual partner in a collision written into the fabric of space-time long before the first humans lifted their eyes to the stars. For years we were taught the encounter would begin in 4.5 billion years, comfortably distant on the timeline. But the realization that our dark matter halos stretch farther, reach deeper, and overlap sooner, forces us to reconsider the script of the future. Halos collide first, not stars, not planets, not the glowing rivers of dust we recognize as the Milky Way and Andromeda. The true meeting begins invisibly, silently, as tendrils of dark matter interlace like two drifting nebulae brushing fingertips across the dark. Some simulations suggest this invisible collision has already started, that we are living within the first whispers of a transformation spanning billions of years. When the stellar disks finally interact, the sky of whatever future Earth becomes will erupt in slow-motion splendor. Andromeda swelling brighter, larger, until its spiral arms stretch across the entire night. It is a future almost too beautiful to comprehend. A slow tidal merging of two great galaxies into one vast elliptical giant. Astronomers already call Milky Way. As Neil deGrasse Tyson often says, we are a way for the cosmos to know itself. And perhaps this future spectacle is the universe watching its own reflection drift toward reunion. But beauty does not erase uncertainty. And so naturally we ask, what becomes of the sun, of the earth, of whatever descendants humanity may have by then? The good news, if we can call it that, is that stars are so far apart that direct collisions are nearly impossible. Our sun will most likely survive the gravitational ballet. But its orbit may change, perhaps flung to a new region of the merged galaxy, perhaps set adrift in a different spiral arm. Earth, however, is less fortunate, not because of the collision, but because the sun will already be on the cusp of expanding into a red giant, long before the galaxies have fully merged. Our world will have been reshaped by the evolution of our own star. Still, it is strangely comforting to imagine that while Earth may fade, the atoms forged within it will continue their journey through the new galaxy, carried into nebulae, folded into new suns, new planets. As cosmologist Carl Sagan taught us, we are star stuff. And in this grand merging, star stuff will simply change form. What makes this entire revelation so moving is not only the science, but the perspective it gives us, that our galaxy's center of mass drifts away from the light, that Andromeda's touch begins long before visible contact, that our sun's path is guided by forces we cannot see. All of it reminds us that the universe is deeper, older, and more mysterious than our intuition ever allows. And perhaps, in this slow cosmic meditation, we find a quiet clarity that nothing in the universe is fixed, not our orbit, not our understanding, not even the center of our own galaxy. Everything flows, everything drifts, everything moves toward reunion. And the more we learn, the more the cosmos feels like a story still being written. If you feel a thought rising within you, a question, a wonder, let it drift into the comments. Tell me, when you imagine two galaxies embracing across billions of years, what do you feel? The farther we drift into the dark, the clearer it becomes that the Milky Way is not the quiet suburban galaxy we once believed. It is a vast shimmering continent of stars, a luminous ocean stretching far beyond the tidy diagrams of textbooks. And when modern measurements doubled its size, every assumption about our cosmic neighborhood began to unravel. Scientists now whisper a new number: 400 billion stars, perhaps more. Neil deGrasse Tyson once said, "We are part of a universe that is under no obligation to make sense to us." And never has that felt truer than in this moment, when the galaxy suddenly reveals itself to be twice as full, twice as deep, twice as alive with possibility. With every star comes the chance for worlds, silent spheres drifting in ellipses of ice and fire, each one a seed of potential. When astronomers extended the Milky Way's radius, its volume blossomed eightfold, and even the most conservative estimates of planets multiplied like dust in sunlight. A larger galaxy means more red dwarfs quietly burning through trillions of heartbeats, more sun-like stars bathing their worlds in gentle warmth, more rogue planets sliding through the dark like wandering spirits. The mind trembles at the arithmetic. If 60% of stars host planets, and a fraction of those cradle temperate zones where liquid water might linger. Then the Milky Way becomes a cradle containing billions of habitable possibilities. Carl Sagan once murmured, "Somewhere, something incredible is waiting to be known." And tonight, that sentence feels like the soft heartbeat beneath every calculation. As the galaxy swells in our models, the number of habitable worlds swells with it. Gently. Inexorably. Imagine a meadow of stars, each blade of cosmic grass tipped with the dew of possibility. Imagine 2 billion planets where rivers may run and clouds may gather. Imagine 20 million worlds where life might have sparked. Quietly. Patiently. And then imagine the rarest bloom of all. A thinking mind. A consciousness looking back into the dark and wondering whether it is alone. If intelligence forms once in a million living worlds, then our galaxy may hold dozens of civilizations, small embers flickering across the cold. Freeman Dyson reflected, "The universe shows us that life is the rule, not the exception." And as the numbers rise, that idea no longer feels like poetry, but inevitability. Yet for every hopeful thought, a shadow follows. The Fermi paradox grows sharper, more echoing, more unsettling in the doubled darkness. If the galaxy is twice as large, twice as crowded, twice as full of planets and oceans and moons, then the silence around us becomes twice as hard to explain. Why does no voice answer across the void? No beacon blink from the horizon? No ancient vessel leave trails of light across the interstellar dark? Enrico Fermi's simple question, "Where is everybody?" deepens like a well. It becomes heavier because the probability of company rises while the evidence remains unchanged. Perhaps civilizations bloom and burn like candles, leaving behind only ash. Perhaps the galaxy is a great forest where the wisest species stay quiet, listening, cautious. Perhaps intelligent life is rare even in a universe bursting with stars, a rare note in a cosmic symphony played mostly in silence. Or perhaps, more hauntingly, more beautifully, more tragically, life is everywhere, but communication is fragile, fleeting, easily lost in the storms of cosmic time. As Stephen Hawking warned, we are only an advanced breed of monkeys on a minor planet of a very average star. Yet our questions stretch far beyond our smallness. Still, something about doubling the galaxy's star count feels like opening the shutters on a long-forgotten window. Each additional star becomes another lantern swinging in the night. Each additional world, another room where chemistry might whisper itself into biology. And even if the universe has not spoken to us yet, perhaps it is still inhaling, preparing its reply across spans of time older than species. Every new discovery reminds us that our expectations are small, our imagination timid, our certainty fragile. In the words of astronomer Jocelyn Bell Burnell, we are still wandering, children in a vast and ancient universe. As measurements sharpen, the Milky Way becomes not just larger but more intricate, more mysterious, more deeply wound with hidden histories. A doubled star count means doubled stories, doubled births, doubled deaths, doubled chances for life to rise, fall, rise again. There is poetry in the arithmetic, a soft murmur reminding us that we inhabit a galaxy brimming with unknown neighbors. Somewhere, around some quiet red dwarf, perhaps a civilization looks up at their night sky, seeing a faint river of starlight, and wonders if anyone else is gazing back. And so we drift, gently, into the heart of the question. A larger galaxy is not just a scientific correction. It is an emotional one, a spiritual one, a widening of the cosmic stage on which life might dance. With each recalculated light year, the Milky Way feels less like an empty cathedral and more like a bustling city of possibilities. The silence no longer means loneliness, but mystery. And in this gentle tension between probability and quiet, between hope and uncertainty, we find the most human feeling of all: wonder. A doubled galaxy invites doubled curiosity, doubled humility, doubled yearning to understand where we belong in the quilt of stars. Perhaps the paradox is not asking us to fear the silence, but to listen more closely. Perhaps the absence of voices is simply the universe giving us time to prepare our own. And as we contemplate these possibilities, drifting like travelers down a slow cosmic river, the question deepens but never darkens. Somewhere in this expanded galaxy, in this doubled refuge of light, life may already be stretching its fingers toward the stars. And the only thing left for us, here on our small blue world, is to keep listening, keep wondering, keep dreaming. The cosmos has a way of humbling us, a way of reminding even the most confident mind that certainty is a fragile thing. For decades we believed we understood the great architecture of the universe, that galaxies were tidy islands of stars obeying clean mathematics, that their sizes were known, their masses estimated, their influence mapped like continents on a cosmic atlas. Yet recent discoveries suggest an unsettling truth, one that drifts through astronomy like a cold wind, whispering that perhaps we have been wrong about everything. If galaxies are far larger than we ever measured, if their halos stretch into the dark in ways our instruments once failed to detect, then every calculation built upon their scale shifts beneath our feet. Edwin Hubble once said, "The history of astronomy is a history of receding horizons." And never has that sentiment felt truer than now, because the horizon is not receding gently. It is snapping backward like a curtain drawn too fast. Larger galaxies mean stronger gravity, denser clusters, deeper wells of influence. And suddenly, the elegant models describing cosmic expansion begin to twist out of shape. If galaxies weigh more than we thought, then the universe should expand slightly slower. Yet the expansion we observe remains unchanged, a contradiction that ripples through cosmology like a note out of tune. Adam Rees, Nobel laureate, once remarked, "When the universe refuses to behave, something profound is waiting to be discovered." And perhaps this is that moment, a moment when the universe rebels against our assumptions to hint at deeper truths hiding beneath the equations. When galactic sizes shift, the very scaffolding of cosmology shifts with them. Standard candles, BAO rulers, supernova-based distance ladders, all depend on galaxies behaving in predictable ways. But if every galaxy is essentially an iceberg, with visible stars only a small tip of a far larger body of dark matter, then our rulers have been shorter than we thought, our candles dimmer, our maps distorted like ancient charts drawn from rumor rather than sight. The Hubble tension, that stubborn disagreement between the early universe and the nearby universe over the speed of expansion, becomes sharper under this new light. If local galaxies are heavier, then their gravitational pull may subtly affect the expansion measurements we once took for granted, heightening the tension, stretching it until it feels like physics itself is fraying at the edge. As cosmologist Wendy Friedman observed, when measurements disagree, the universe is telling us something. And lately, it feels as though the universe has begun raising its voice. A larger Milky Way, a larger Andromeda, a larger cosmic web threading the darkness. All of it pushes us toward a single inescapable realization. The universe is suddenly denser, not because new matter has appeared, but because our ignorance has been peeled away. A denser universe reshapes everything, from the formation of the first galaxies to the rhythm of cosmic expansion, and even the life cycle of dark energy itself. Dark energy, that mysterious pressure stretching space apart, has always been a delicate balance against gravity. But if gravity was underestimated, then dark energy must be stronger than we believed. Or perhaps it is not constant at all. Perhaps it evolves, responding to cosmic growth like a tide shifting with an unseen moon. Some physicists whisper of interacting dark sectors, fields entwined with dark matter, nudging the universe in ways we barely perceive. Others wonder if our theories of gravity itself need softening, not broken, but bent gently like reeds in a cosmic wind. Each discovery echoes with a sense of déjà vu, recalling moments when science once stood on uncertain ground, peering into the dark, unsure whether it was glimpsing truth or shadow. When Vera Rubin measured the strange speeds of stars in galaxies, she said, "The universe is not only stranger than we think, it is stranger than we can think." Her words return now with haunting clarity, because as galactic scales swell, the strangeness deepens. The familiar dissolves into wonder. Imagine drifting through a galaxy whose true boundary fades like mist, where stars thin into loneliness, where the halo stretches so far that the silence itself feels gravitational. In such a place, human certainty becomes as fragile as starlight. Our equations only lanterns in an endless night. And yet, there is a quiet beauty in watching our understanding evolve, like a constellation slowly shifting shape. If galaxies are larger, then their interactions are more intimate, their halos brushing against one another long before their stars collide. It means our local group is a crowded sea, a dance of giants rather than distant neighbors. It means cosmic structure forms with greater urgency, threads thickening, knots tightening. And it means our models must grow softer, more flexible, more willing to listen to what the sky is telling us. In the meditative drift of this cosmic thought, one begins to sense that science and wonder are not adversaries, but companions, walking hand in hand across the dark. We measure, we revise, we learn. And through this cycle, the universe reveals itself not as a puzzle to be conquered, but as a story that invites us to read slowly, gently. The galaxies were never small, never simple, never confined to the neat diagrams in our textbooks. They were always vast beyond imagining, always stretching farther, always keeping secrets just beyond the reach of our telescopes. Now, with clearer eyes, we see them for what they are, and in doing so, we glimpse a universe richer, deeper, more intricate than the one we thought we knew. Perhaps the real discovery is not that galaxies are bigger, but that our willingness to grow with the universe has made us bigger too. The deeper we peer into the Milky Way, the more it behaves like a vast riddle written on shifting sands. A cosmic poem whose lines erase and rewrite themselves as our instruments grow sharper. For decades, astronomers believed they understood the balance sheet of matter, the delicate accounting of gas, dust, stars, and the unseen forces that cradle them. But with the revelation that our galaxy is nearly 3 times larger than once taught, an unsettling truth rises like a cold dawn. Half of the normal matter we expected simply is not there. It vanishes into silence, like a whispered name carried off by interstellar winds. This is the problem of the missing baryons, one of the most haunting mysteries in modern science. A puzzle so vast that even dark matter seems easier to embrace. When the galaxy expands in our understanding, the amount of baryonic matter it should contain expands as well. An inevitable mathematical tide. A galaxy 3 times larger should cradle 3 times the mass in stars and gas. Yet the universe answers with a quiet contradiction. The stars we count, the clouds we map, the glowing nebulae we cherish in long exposures, they add up to only half of what the physics of the cosmos demands. Frank Wilczek once reflected, "The universe is not only stranger than we imagine, it is stranger than we can imagine." And nowhere is that truth more palpable than in this invisible deficit wrapped around us, shaping our spiral without ever revealing its face. Some say the missing matter was expelled, blown into the circumgalactic deep by supernova winds, hot enough to glow yet too faint to see. Others whisper that it never truly joined the Milky Way, lingering in the outer reservoirs like forgotten pages from the galaxy's early story. Even more suggest it hides as cold shadows, wandering planets, dim brown dwarfs, or diffuse filaments of ionized gas stretched thin across 1,000,000 light-years. But the more we search, the more the mystery deepens. It is as if nature placed the answer behind a curtain woven from the cosmic microwave background itself, softly laughing at our persistence. And as we confront this vanishing half of our galaxy, another revelation emerges, quiet yet monumental. The local group, our small celestial neighborhood, must be redrawn entirely. Distances we memorized in childhood textbooks dissolve, boundaries we trusted falter, and the architecture of our cosmic home shifts under our feet like drifting dunes. Andromeda, once believed to linger at a comfortable distance, now stands closer than our old maps allowed, its halo reaching toward ours like 2 ancient giants extending their hands across the void. As Astrophysicist Sandra Faber once said, "Galaxies are not islands. They are ecosystems. And ecosystems breathe into one another, reshape one another, and in time, merge into something new." Triangulum, long admired as an independent third sibling, is no longer so autonomous. Evidence suggests its orbit may already bow to Andromeda's gravity, like a bird pulled gently into the swirl of a larger flock. If so, the local group is not three great spirals suspended in harmony, but a complex gravitational braid. Andromeda leading the dance, the Milky Way responding, and Triangulum circling like a watchful companion. The dwarf galaxies scattered across our sky become contested children, their allegiance uncertain, some wandering between halos like nomads crossing the borders of invisible empires. With each new measurement from Gaia and Webb, we discover that our galactic boundaries are not walls, but porous membranes. And then comes the question that unfolds like a black flower in the dark. Have the halos touched yet? The thought alone carries a quiet weight. For if the Milky Way and Andromeda's dark matter envelopes have already begun to interpenetrate, then the first chapter of our eventual merger is already underway. Two titans drifting toward one another in slow motion, their invisible bodies meeting long before the stars ever collide. Neil deGrasse Tyson once reminded us, "We are part of this universe. We are in this universe. And perhaps more important than both, the universe is in us." If our halos are touching, then, in some profound sense, we are already entangled with Andromeda. This redrawing of the local group ripples outward into the equations that scaffold our universe, especially those describing dark energy. The cosmological constant, that quiet pressure stretching space itself, depends on our understanding of how matter is distributed. If galaxies are heavier, if gravity reaches farther, if halos overlap where we once imagined emptiness, then the balance between matter and the invisible force driving expansion shifts like a candle flame in a silent room. Some fear the change, believing it complicates a model already delicate. Others welcome it, seeing in it a chance to touch a deeper truth. As Wendy Friedman once said, "The universe always humbles us, just when we think we have it figured out." Perhaps dark energy is not uniform after all. Perhaps it ebbs and flows subtly among vast structures, shaped by the invisible scaffolding of dark matter. Perhaps the missing baryons themselves whisper clues, hiding in warm clouds, faint X-ray halos, or the quiet interstices where galaxies trade matter like drifting pollen. Every new observation bends the old models, stretches them, tests their resilience. And in this stretching, in this quiet breaking and mending, science breathes. The universe does not owe us simplicity. It offers instead a kind of cosmic poetry, a shifting tapestry woven from forces we barely grasp. And as we float here, tiny beings drifting in a starlit ocean, we are invited to listen, to wonder, to follow the threads even when they vanish into night. The missing baryons, the redrawn local group, the trembling of dark energy models, all remind us that knowledge is not a solid shore. but a tide that moves beneath our feet. And so we continue, with instruments that see deeper, with minds willing to be humbled, and with hearts that still thrill at every whisper from the dark. For the galaxy is larger than we knew, the matter stranger, the bonds between galaxies more intimate. And somewhere in that vastness, the truth waits, shimmering like a distant star. The universe drifts without edges, a vastness without walls, a silence without borders. And in that boundless expanse, our old instincts to draw lines, to name borders, to carve boundaries into infinity, begin to crumble. For centuries, humanity pictured a galaxy as something solid, a spinning island of stars with a firm outline. But as we look deeper, we learn that a galaxy is not an object at all. It is a region, a gravitational influence, a slow fading of starlight into the dark. It breathes as softly as mist, thins gradually like dusk, turning to night. And what we once thought of as an edge is nothing more than a human invention pressed against a cosmic truth that refuses to stay still. Scientists like to define things, to measure, to capture. Yet a galaxy slips gently between our fingers, scattering into distances where stars are separated by tens of thousands of light years. The Milky Way does not stop suddenly. It simply becomes quieter, its stars fewer, its gas thinner, until the night turns almost empty, but never completely. As astrophysicist John Inasto once whispered, "The universe is not a collection of objects. It is a collection of relationships." And galaxies are exactly that. Relationships of matter and gravity, held together by invisible threads. When we try to measure the size of a galaxy, we are not measuring a body. We are tracing the reach of its gravity, the domain where its pull still matters. That is why the Milky Way is not a fixed shape, not a crisp spiral drawn on a textbook poster. It is more like the glow of a lantern in fog, bright at the center, then fading more, until the light becomes indistinguishable from the night around it. Astronomer Vera Rubin said it beautifully. The edge of a galaxy is where the stars stop following the rules. And indeed, the moment the motions lose pattern, the galaxy dissolves into the larger sea it inhabits. This is why measuring size becomes a matter of choice, not a matter of fact. If you measure where the bright stars end, the galaxy is small. If you include the faint red dwarfs scattered thinly across the halo, the galaxy grows. If you measure where gravitational binding remains strong enough to hold satellites, the galaxy grows again. And if you consider the dark matter halo, a ghostly sphere extending far beyond anything our eyes can see, the galaxy may stretch 1,000,000 light years across. In such a universe, borders are merely approximations, soft suggestions, not truths carved in stone. For generations, astronomers tried to map these shifting boundaries using the limited sight of optical telescopes. But dust and distance swallowed the truth. And then, as if the universe finally decided we were ready, a new pair of eyes opened in the cold shadow of L2. The James Webb Space Telescope. With its golden mirrors and deep infrared vision, it looked not at what is bright, but at what hides. and in doing so snapped the spine of our old model. Webb revealed stars in regions we once believed were empty. Faint halos of ancient suns, drifting in orbits far beyond the supposed edge of the Milky Way. It traced stellar streams hundreds of thousands of light-years long, showing that our galaxy's gravitational reach stretches much farther than our ancestors imagined. It measured how distant galaxies bend around the dark matter of our own, proving that our halo is not small, not tidy, but immense. And this magnificent instrument confirmed what a few scientists had quietly suspected for years, that the Milky Way is not 100,000 light-years across, but closer to 200,000 or more, doubling the stage on which the story of humanity unfolds. Why Webb and not Hubble? You might ask. Hubble sees the universe in visible light, a beautiful but limited language. Webb sees in infrared, the wavelength of age, of dust, of hidden things. Where Hubble sees a wall, Webb sees a window. Where Hubble sees darkness, Webb sees structure. As Nobel laureate John Mather once said, "Infrared is the light that remembers, and Webb is the instrument built to read that memory." Because of Webb, we now understand that galaxies bleed into one another through overlapping halos, that our Milky Way's invisible sphere already brushes against Andromeda's, like two storms whose winds meet long before the clouds collide. The idea of my galaxy and your galaxy becomes blurred, almost poetic. In reality, these structures we name are part of a single continuous web, an interlaced choreography of matter shaped by the same cosmic forces stretching back billions of years. And in this understanding, something gentle happens, something almost human. We realize that boundaries are comforts, not truths, that the universe does not believe in fences, only gradients, that the cosmos is less like a set of islands and more like a rising tide. And perhaps that is why the act of measuring becomes an act of humility, an acknowledgement that we are building maps inside a territory whose nature is fluid, shifting. Webb's findings did more than update numbers. They softened the rigid edges of our imagination. They remind us that science is not about certainty, but about pursuit. Not about drawing hard borders, but about learning to live within the questions. As astrophysicist Katie Mack once reflected, the universe is under no obligation to make sense to us. And yet, we seek, we measure, we dream. When you look up tonight, think of the galaxy not as a shape, but as a presence, a soft gravitational breath spreading across the darkness, its edges nowhere and everywhere. Think of the stars wandering at its outermost fringes, drifting like lanterns lost at sea. Think of the unseen halo around you, passing through your body, silent as a prayer. And let that immensity settle gently into your chest, the way quiet settles over a sleeping world. Because to understand this universe is to surrender to its softness, its refusal to stay inside definitions, and to accept that the cosmos is more like a meditation than a machine, more like a poem than a diagram. Science brings us the tools, but wonder carries us the rest of the way. And as Webb continues to peel back the layers of our celestial home, we learn again and again that the absence of edges is not a flaw. It is the very language of the universe. So breathe with it, drift with it, and allow the boundless sky to remind you that every boundary we see is only an echo of our own longing for certainty, while the universe itself flows freely, endlessly, without edges, without walls, and infinitely open to those who dare to look a little deeper into the dark.